Welcome to episode 151 of Paper Brief, where we dive into fascinating AI research papers. I'm Charlie, your host, and with me today is Cleo, a tech and ML whiz who's here to shed light on some pretty cutting-edge stuff. Today, we're discussing HyperDreamer, hyper-realistic 3D content generation and editing from a single image. How cool is that? Cleo, can you give us a quick teaser about what makes HyperDreamer stand out?
Absolutely, Charlie. What's really exciting about HyperDreamer is how it tackles the dream of creating highly realistic 3D models from just a single image. The team behind it introduced a framework that generates 3D content that's not just viewable from any angle, but also fully renderable and editable, which is a big deal compared to previous methods.
Right, the 360-degree viewable aspect sounds like a game changer. But what do they mean by renderable and editable? How different is it really from what we've seen before?
The difference is quite significant. HyperDreamer incorporates semantic segmentation and data-driven priors to learn the material properties like albedo and roughness, so it can predict material shades that look convincing from any perspective. Plus, an interactive editing feature lets users select regions on the model and edit textures with just text commands. Imagine saying, "Make this part look like gold," and it just does.
That's like having a magic wand for 3D modeling. So, they've made it really user-friendly then, which opens up a lot of possibilities.
Exactly. It democratizes the whole process. Regardless of your skill level, you can produce personalized 3D content that's high quality and practical for a multitude of applications, from gaming to virtual meetings.
It's unbelievable how far technology has come. But how did they manage to achieve this level of detail and flexibility? What's under the hood of HyperDreamer?
Under the hood, the authors introduced a novel super-resolution module that works with pseudo-multi-view images to supervise high-res texture generation. They're leveraging the so-called segment anything model for online 3D semantic segmentation. Plus, the framework handles appearance variation with a spatially varying reflectance model, which ensures each material looks right from every angle.
I heard that some other methods had issues like a 2D diffusion bias. How does HyperDreamer deal with those?
That's a great observation. They address the 2D diffusion problem with a semantic-aware albedo regularization loss to reduce biases from the original 2D training data. So the colors and the way light interacts with the object surfaces are going to be more natural, minus those earlier biases.
With all these features, HyperDreamer must blow the competition out of the water. Did the paper mention how it stacks up against other methods?
They did, and the proof is in the pudding, or in this case, the results. Extensive experiments demonstrated that HyperDreamer surpasses the current state-of-the-art methods by a significant margin. We're talking about better 3D generation and editing quality here.
That's really impressive. 3D modeling is such a complex field, and this sounds like a huge leap forward.
A leap indeed. And this isn't just for researchers. It's expected to find its place in all sorts of practical domains. I'm keeping my eye out for how this will shape up the future of virtual content creation.
I can't wait to see where this goes. Thanks so much for walking us through HyperDreamer, Cleo. It's been a fascinating chat.
Always a pleasure, Charlie. Can't wait to be back to explore more AI frontiers with you.
And to our listeners, thanks for tuning in to this episode. Remember to check out HyperDreamer's paper for the nitty-gritty details. Until next time, keep dreaming big with AI.